Hello everyone, and welcome to the solution for implementing a queue using two stacks interview problem. So again, the problem statement was given the stack class below, implement a queue class using two stacks, and you were allowed to use a Python list data structure as your stack. So, what was the solution? Let's go ahead and zoom in a bit. Whoops. So the key insight is that a stack reverses the order, while a queue doesn't when you're pulling stuff out of it. So that was the main key, and we mentioned that when we were going over the stack theory lecture. So always keep that in mind, that as you pull stuff out of a stack, you're reversing the order of which you put them in. So a sequence of elements pushed onto a stack, remember, becomes reversed when you pop them out. So consequently, two stacks chained together will return elements in the same order, since reversed order, reversed again, is original order. So that's why this is such a classic interview problem. It really checks that you understand what both a stack and a queue is. So we use an in stack that we fill when an element is on queued or enqueued, and the dequeue operation takes elements from an out stack. If the out stack is empty, we pop all elements from the in stack and push them into the out stack. So you were given some filler code. Let me go ahead and zoom out here. Given this class, and then two stacks, and you're supposed to fill in the onQueue or enqueue, and then the dequeue. So what we're going to do is rename these stacks into something that will show the logic a little better. We'll have an in stack and an out stack. Okay. So what we're going to do for onQueue, or adding elements into that queue, is say self dot in stack, and we'll append that element. So that's all we have to do for the onQueue. We just take the in stack and then append it, basically pushing it onto the top. And then the dequeue is where we have to do that double reversal. So we're going to say if not self.outStack while self.inStack, and this is basically the checks for the empties, what we're going to do is add the elements to the out stack to reverse the order when called. So I'm going to say self.outStack.append, and I'm going to append the popped element from the in stack. And then all I have to do is just return self.outStack.pop. Okay, so this is really the key insight here, these two lines. One for that in stack where you just have to append the element, and the other for that dequeue. So remember that we have a stack that's going to reverse order when a sequence of elements is pushed onto a stack or on a stack. It's going to come back in reverse order when popped. So that means that two stacks chained together are going to return elements in the same order. Since we're reversing them twice, we just reverse, and that's the original order. So what we're doing is we're using this in stack right here, and we use that in stack when we fill an element. It's enqueued, and the dequeue operation takes elements from that out stack here. So if the out stack is empty, what we're going to do is pop all elements from the in stack right here, and then push them onto the out stack. Okay, so this loop is basically checking the empties for that particular piece of logic. So using that in stack, we fill when an element is onQueued, and then the dequeue operation takes elements from an out stack. If the out stack is empty, we pop all elements from the in stack, which is why we say here while self in stack, and then push them onto the out stack, which is what we're doing in this line. Okay. So go ahead and code out the solution. Make sure you can do this from memory, or at least from your memory of the theory of queues and stacks, because it is a really common interview problem. Alright, thanks everyone, and that's it for the stacks, queues, and decks lectures and section of the course. What you should have gotten out of this is a full understanding of stacks, queues, and decks, how to implement each of those, and then how to use their logic for interview problems. All right, Thanks everyone, and I'll see you at the next lecture.